Welcome 8th grade. Today we talk about compounds and mixtures. Now with compounds and mixtures, we got quite a bit going on. We will talk about their properties and how they come together and all those fun and dandy things. All right, so substance. We have to first know what a substance is. That is matter that has the same composition and properties throughout. All right, matter with the same composition and properties throughout. Well, that's something like the gold you see here, the metal. That is what a substance is. It is all the same all the way throughout. It is pure, what they're going to call it. Okay? It's made of only one element or compound. All right? Now, a compound is something that's a little bit different. It's more specific. A matter whose smallest unit, a molecule, it must be a molecule, is made up of atoms of one or more than one element bonded together, like H2O. H2O is a compound. The properties are different from the elements that make up the compound. We think of like water. H, hydrogen, that's a gas. O, oxygen, that's a gas. They come together, they're naturally in the liquid state. Again, we see hydrogen, oxygen, and hydrogen peroxide. Hydrogen is a gas, oxygen is a gas, and when they come together, they're in that stuff that you pour on a wound and it bubbles up. They do turn back into gases, but they stay in the liquid form most of the time. Now salt, something like sodium and chlorine. Sodium is hydrophobic. It will burn you if you touch it in the pure state because it'll leach all the water from your skin. Chlorine, they actually used chlorine gas in World War I as a poison to go into the trenches and kill people. Yet, when we put sodium and chlorine together, they're edible table salt. All right, there's the picture of the chlorine gas that is green. All right, there it is from World War I. All right, there's sodium. Notice he has gloves on so he doesn't get burned. And we put them together, we get table salt, which you eat every day. Two poisonous things come together to be something edible. Now, compounds in the molecular formulas. Hydrogen peroxide was H2O2. And we see right above there, oh, that's what the molecular compound would look like. They go together in certain ways. Now, salt, table salt is NaCl, one of each. Notice the minus sign and the plus sign. All right, with the minus sign and or the plus sign, that means they're ions and they attract to one another. All right, and then H2O, hydrogen and oxygen, they fit together in a Mickey Mouse shape, and that's what gives water some of its cool properties, like the ability for the drop to bubble up. Okay? Now, I'll move this here real quick so you can see what it says down at the bottom. So, compounds, molecular formulas, whose smallest unit, the molecule, is made up of atoms of more than one element. Every atom in that bottle of hydrogen peroxide is H2O2. Every piece of salt, the molecule is NaCl. Every molecule of water is H2O. All right? Letters tell the elements. The H is the hydrogen, the O is the oxygen. And the numbers, that subscript, tells the amount of that element. So, water, 2 hydrogen for every 1 oxygen. Sodium, 1 chlorine for every 1 sodium. Hydrogen peroxide, 2 hydrogens for every 2 oxygens. Every molecule is like that for these. Okay? Now, what's the formula? So as you look at this, we're going to look at this number 1 here. 2 H's together, well, that would be H2, or it's hydrogen. That's the gas that's out in the universe. O, well, there's 1 O, 2 O's, O2, or oxygen. That's the oxygen we breathe every day. N, it's 2 nitrogens, nitrogen, okay? Chlorine, NO is nitrogen oxide, all right? 2 chlorines, that's Cl2. See, we have the letter or the symbol for the element and the number of the subscript. Number 6 should be familiar, H2O. Number 8, NO2. So That would, number 7 would be CO2, carbon dioxide. You maybe heard of that before. Breathe it out every second of the day. Then we have NO2, nitrogen dioxide. All right. Those are all telling us that every molecule in a gas that would have nitrogen dioxide in it would have one nitrogen and 2 oxygen in it. When we breathe out the carbon dioxide, every molecule of that has 1 carbon, 2 oxygen. They fit together that way. CH4. How many elements make up this compound? So if we look, 1, 2 elements. There's hydrogen and there's carbon. Now, I ask a different question. How many?
Mrs. Devil, call Mrs. Valerie at 203, please. Thank you.
Now I ask this question. How many atoms make up the molecule? There's 1 carbon. There are 4 hydrogens, so it's 5 atoms make that up. All right? 2 elements, carbon and hydrogen, but 5 atoms because there's 1 carbon and 4 hydrogen. And it fits together like that. That's methane. Methane is what makes your farts stink, literally. All right? So you can see the black in the middle, that's your carbon, and your 4 white dots there, that's the hydrogen sticking to it. All right. Now in this one, this is glucose from photosynthesis. How many elements make up this compound? When we look, the number of elements, we have carbon, we have hydrogen, we have oxygen. That's 3. 3 different types of elements make up the compound. Now they ask how many atoms make up one molecule. Well, 6 carbon go together with 12 hydrogen and 6 oxygen. Oh, that makes 24? Would that be right? 24 atoms, because 6 plus 12 plus 6 is 24. All right, and there's what a glucose molecule looks like. We have the gray and the white and the red. All right. Now, as we move on, 2 substances come together, but they don't make a new substance. Every time we had a compound, 2 substances came together, chemically formed for a compound, then they made a new substance. Now, that's not going to happen. 2 come together, but they don't make a new substance. We have a mixture. Now, we have 2 types of mixtures that are next to each other. Heterogeneous mixture and a homogeneous mixture. Now, hetero, I am going to use this, heterosexual. There's 1 male and 1 female in a heterosexual relationship. Homosexual, that means there are 2 females or 2 males in a relationship. So those prefixes mean something. Heterogeneous means different throughout. Homogeneous, the same throughout. That is why I bring up the point that I brought up before. With a heterogeneous mixture, not the same throughout. Homogeneous, it is the same throughout. Larger parts that you can see, usually in the heterogeneous. Not always, but usually. Smaller parts that you cannot see, that's generally as well. An example might be a fruit salad. Do you see how we have kiwi and strawberries and grapes and apples and all those things together? They're still all those things, just they're mixed together in one pile. All right? Each thing keeps its own properties. Something like Kool-Aid is a homogeneous mixture. All right? You see the red, sweet water there? All right? The water and the Kool-Aid, the solvents mixed, and we have something that's new. It's evenly mixed throughout. Fruit salad, if I take a bite over here and a bite over here, I wouldn't get the same fruits. They're not the same throughout. This drink up here is the same as this drink out here if they are stirred evenly and not saturated. That means they have too much sugar in them where it sits on the bottom. Other examples of a heterogeneous would be like a salad. Again, if I take a bite over here or a bite here, I get different amounts of cheese. Heterogeneous, different throughout. Where's the air? Breathe it in. Oh, over here, I get 75% nitrogen, 22% oxygen, and trace gases. Over here, I get the same exact thing. It is the same throughout. Now, homogeneous and heterogeneous mixtures, you can learn a lot. This video has been added to the Google item. And then compounds versus mixture, another video that's been added. I won't play them on this screen. You guys are smart enough to use them there, and the sound is not very good when I play it to share it. All right, I thank you very much, guys. You've been a